Okay guys, so today what I want to talk about is why we do expanding and factorising, and what they are. And I guess the first thing to think about is expanding and factorisation are actually kind of two sides of the same thing, of the same coin. So to move from an expression like 7 bracket x plus 2 bracket to 7 x plus 14 is called expanding, and to go from something like 7x plus 14 back to 7x plus 2, we call that factorising. So when the reason we change between them is sometimes it's easier to work in this form depending on what we're doing, and sometimes it's easier for us to work in this form. And I'm hopefully going to show you one example of why we do this. There's a real world example which hopefully could make things a bit more intuitive for you guys. So let's break down this 7x plus 2. What that is saying is we've got 7 lots of x plus 2, or 7 groups of x plus 2, and I could actually write out those 7 groups here, and that's what I've done. We've got 1 group, 2, 3, 4, 5, 6, 7 groups of x plus 2. And if we add all the x's together, we end up with 7 lots of x, and if we add all the 2's together, we get 7 lots of 2, which is obviously, if we collect those like terms, we end up with 7x plus 14. So we've moved from our 7x plus 2, 7 bracket x plus 2 I should say, to 7x plus 14. And that's the kind of distributive property or distributive law in mathematics. And it works pretty well. When we've just got a number out the front like 7, it's pretty easy to understand that we've got 7 lots of everything in the bracket. So we've got 7 lots of x plus 2. I think it starts to get a little bit trickier when we look at something like bracket x plus 3, bracket x plus 2. And the way you need to break this down is it's saying we've got x plus 3 lots of x plus 2. And one way to think about that is we've got x lots of x plus 2 plus 3 lots of x plus 2. And if we add that together, that will give us x plus 3 lots of x plus 2. So how would we write this? Well, x lots of x plus 2 plus 3 lots of x plus 2. Mathematically, we could write that as x lots of x plus 2 plus 3 lots of x plus 2. Now, if we go through to distributive law like we did earlier and expand these two simpler expressions, we'll end up with x lots of x, which is obviously x squared, x lots of 2, which is 2x, 3 lots of x, which is 3x, and 3 lots of 2, which is 6. Collecting the like terms, so we've got x to the power 2, there's no other x to the power 2, so that stays by itself. We've then got 2 lots of x to the power 1, or x, so we've got 2 plus 3x, which is going to be 5x plus 6, which we then write as x squared plus 5x plus 6. What about something a little bit trickier, like x plus 1 bracket x minus 2? So this is saying we've got x plus 1 lots of x take 2. So another way we could rewrite this is x lots of x take 2 plus 1 lot of x take 2. Going through the same procedure, so we've got x lots of x, which is x squared, take 2x, which is the x times the negative 2, plus 1 lot of x, which is plus x, plus 1 lot of negative 2, which is take 2. So adding a negative is the same as subtracting 2. We then need to collect like terms. Again, we've only got 1x to the power 2. We've got a negative 2x plus x. So if we've lost 2x and we find one of them, we're still lost 1x. So take x, and then we've got the take 2. So we've expanded these brackets, and really what I hopefully eventually we'll get to is a point where we can see something like x squared take x take 2 and go through this process backwards essentially or think about how we might get, what kind of expression or equation would lead us back to this point here. So let's now look at a real world example. So what I've got here is an equation, and this is negative 5x squared plus 5x plus 10. And this, if you graph it, it looks something like this. This kind of parabolic shape. It's kind of goes up, starts slowing down, and then drops back down like that. And I guess one way to use this kind of mathematics is to talk about movement of projectiles. And factorising, in fact, has something to do with working out how long a ball kicked off a bridge will take to hit the ground. So if you can factorise an expression, that will actually tell you some information about how long a ball takes to hit the ground. So a simplified expression for a ball kicked off a 10-metre high bridge, and if we imagine this here is height at 10 metres high, so the bridge is 10 metres high, a ball is kicked up in the air and then it drops back down to earth. If we kick this ball with an initial velocity of 10 metres per second in the up direction, and gravity is acting on it in the down direction, we can write this as negative 5x squared plus 5x plus 10. So let's factorise this expression. The first thing we might want to do is, basically we pretty much hate having anything in front of the x squared that's not 1 when we're trying to factorise. And if we can get away from it easily, we will. So in this case, I want to get rid of this negative 5. So I'm going to put the negative 5 out of a big set of brackets, and then going to see what that effect is. So if I'm effectively going to divide everything by a negative 5. So I put the negative 5 out the front, and then if we put the brackets, we've got negative 5 times x squared. That's what gives us our negative 5x squared. I put a negative x here, and that's, if we do negative x times negative 5, that gives us the plus 5x. And if I do the negative 2 times negative 5, that gives us a plus 10. So this here is identical to this here. Two representations of the same thing. What I now want to do is work at factorising this component of it here in the brackets. And one way, I'm going to jump into factorising it just so you can see what happens. But we can see we've got, well, this is actually very similar to the one we did on the last page. We had x plus 1 and x take 2. Now we've got an x squared take x take 2, and we know that this is an equivalent to this. So this is why I'm going to kind of jump ahead here. So we've got negative 5 lots of this factorised expression here. So as I said up here, this graph is of negative 5x squared plus 10. This is the graph here. And if we look closely, I might write the factorised version here. So we've got negative 5x plus 1, x take 2. And if we look closely, we can see that, and this is time in seconds across here. So this ball is taking, and this up and down is height off the ground. So the ball is on the ground when it's on the x-axis. And we can see that this graph collides, or crosses, I should say, the x-axis at 2 seconds. And this tells us that our ball will have hit the ground after being kicked off this bridge at the 2-second mark. And that actually relates to this little part here. We can see there's another, so this is, if we change the sign here, this becomes positive 2, and this fits in right here. The other one, if we change that to negative, that fits in right there. And later in the year, we'll talk about why that is. But for now, that's where I'm going to leave it, because my video can only record for 10 seconds. But this is one of the reasons we